Let's look at a different graph now. In this case, we have acceleration on the y-axis. Acceleration is meters per second squared, and time on the x-axis. Notice how we label both axes with the variable and its units. So we now have an acceleration time graph. We can find the velocity of a moving object using this graph. When the acceleration is constant, which is the only kind of acceleration we'll deal with in this class, the velocity is changing by the same amount each second. This is shown on the graph as a straight horizontal line. At every point in time, the acceleration will be 3 meters per second squared. In order to find the change in velocity for a certain time period, we will be calculating the area under the acceleration line that is limited by the time interval. And just think about that. If we're finding an area, let's just say we wanted to find the velocity at 12 seconds, we're multiplying a times t for the area. That's just kind of simple geometry, length times height, and that will give us a velocity. We're giving this graph and we want to find out the change in velocity over the first 12 seconds. So we have a constant acceleration of 4 meters per second squared, and then we also are taking this out at 12 seconds. So if we just look at the area under the acceleration line, we have a height here of 4 meters per second squared and a length of 12 seconds. So let me just put the right units here. If we were to multiply these two numbers together, we can clearly see we'd get this area. That's just basic geometry. And the units, you have meters per second squared times seconds. The seconds cancel out to one of those seconds there, and we get an answer of 48 meters per second. So the change in velocity during the first 12 seconds of this motion is 48 meters per second.